welcome to class. Welcome to video 9 of CS202. Hope you all are doing good. Yeah, that was random, yes. I clicked that timer instead of the generic timer. So, yes, hello there, everybody. So, today we're kind of switching gears a little bit. We're still kind of talking about pointers, but we're gonna be moving more into talking about virtual functions and what those are and how they, well, we'll talk about that. And then we will talk about up and downcasting, which has to do with pointers, but we will be using virtual functions to kind of help us with that as well. So yes, very interesting stuff today that we will be talking about, actually. So let's go ahead and start by looking at the book and talking about do we want to talk about the disk pointer first, or shall we jump into virtual functions first? I think I should add this pointer in here, and then that way I don't forget to talk also about that. Yes. So yes, we want to also talk about the disk pointer. Okay, so let's start with talking about virtual functions. Okay, so let me propose to you a situation where a virtual function would be useful. Okay, so suppose that we're going into the topic of inheritance and aggregation and those kind of things. Suppose that I'm trying to make we were doing ships, right? We were doing ships. So I was trying to make a class called ship, which had, some stuff in there. Let's say maybe it has a string name. And let's make everything public. So it's a string name, and maybe it has a function foo that does something, okay? Doesn't really matter what it does, but there's some variables and some functions, okay? But what you're really trying to do with this, and as we were trying to do at that point, is you really want to inherit that into different kinds of ships. So maybe we have capital ships, that inherits from ship publicly. But also you have like a fighter, it's like a light class ship, okay? So we'll call them fighters. And they both share basically what ship gives them, which is they both have a name and they both have the function foo in there. But in addition to that, they might have things like the capital ship maybe has actually a fighters that it can carry. So you could have something like fighters, 10 of them or something. Of course, we could do this dynamically or whatever. And then in addition to that, it might have I don't know, a nickname, or that will be under the name. So maybe a capital ship has, what could a capital ship have that a fighter ship might not? That might be hyperdrive engines, So we'll say Boolean has hyperdrive, I guess. Well, no, that's not really a good thing. Let's just say, I don't know. Let's just leave it like that, actually. And then the ship has a pilot. So we'll oh yeah. So then this one we can say string captain, and that's actually the name of the captain. So we'll leave it just not initialized at all. And then the ship might have a pilot. And maybe it also has like gunners, like a gunner seat. Okay? So the point is that you have this ship class, and then you have all these derived classes. And you might even have derived classes down here, right? You might have different kinds of fighters, like you have a bomber, and you have or a light fighter and a heavy fighter, those kind of things, right? And you might have different types of capital ships and so on. So this sort of hierarchy could keep going. But here's the thing. When I'm writing code in main, when I'm actually out creating an object of these classes, if I want to make a capital ship, you know, I can go ahead and say capital ship, and then I can say Star Destroyer. So I'll put SD for Star Destroyer. Okay, SD1. Or here, I'll just call it an Venator. I think that's one of the names. Okay, if I want to make a fighter, I can go ahead and say fighter gets me a TIE fighter. You know, and I can go ahead and do this kind of thing. However, the way that I have this code, in theory, I could also just go ahead and say ship TIE fighter or TIE fighter 2, right? And this is a problem. This is a problem that we didn't really think about, but it was present all this time. And that is, when you're doing your inheritance, the idea of this sort of commonly shared classes may not be that you necessarily want to make an object of those classes. You may want to make objects of the derived classes, and sort of you have sort of intermediary classes that are only really meant to sort of extend other classes, but are not all really meant to have objects of themselves, right? Because for example, if you extended this into being like a TIE fighter, and you know, here an X-wing, a Y-wing, and those kind of things, those are actual ships. But you don't have a ship that's called fighter, right? Or if you only have one kind of ship and it is called fighter, then that's okay. But you don't really have a ship that's just called ship, because what is that? It's not a category, right? Another example of this is the old example that I gave my other class, and that was animals. You know, if you were doing this with animals, you know, you could have a class called the animal, which also just has a string name and maybe like an age as well. Right, and then you go ahead and you inherit this class and you make a type of animal. So maybe you make a chicken. So you make class chicken, and not all the publics as necessary. Okay, that inherits from animal, and that has its own things like, you know, whatever chickens do, lay eggs. Okay, and then you could also have a class called dog that also inherits from animal. And so on, right? So what you essentially end up with is a hierarchy that looks like this. Animal, there's a dog, chicken, and cow, right? But the thing is, when you're creating objects, you want to make dogs, you want to make chickens, and you want to make cows, right? You don't just want to make an animal, because that doesn't really make sense. There's no animal, there's an animal. I mean, all animals are animals, all dogs are animals, but there isn't a individual species or living thing that we just called animal. Right? It has a specific name. It's a dog, it's a cat, it's a chicken, human, whatever. They are animals, but there isn't an animal that is just like an animal has no name. So hopefully that makes sense, right? We never want to make an object that's just called animal, because it's like, what is that? It's not a chicken, it's not a dog, it's just an animal. Like, that doesn't make sense. So do you guys get that, the idea behind why we don't want something to be made of a class animal or a class ship, and why those are really only meant to be there as blueprints for the actual classes, right? So you have an animal so that you can not have to put all the string names to the dog, the chicken, and the cow, or the same with the ship. You have to just as a sort of a class that shares all your common attributes, but it's not really, you don't intend the end users to actually create objects of this class. You intend for them to create, oh, let me bring the microphone closer. You intend for them to make objects of the derived classes, but not of the superclass. That is just meant there to sort of simplify your code, right? Nobody's saying anything in chat, but do you guys kind of get the idea of where I'm coming from this? I gotta make sure that you guys are alive. Tell me, are you guys alive? Yes. Okay. Cool. So basically. Okay, good. You guys get it. Good, great. Right. So we want to be able to limit. And yet again, this comes back to the idea that we were talking about some time ago about limiting what people can and can't do, not necessarily as a security thing, but more of as a way to avoid mistakes, right? So we never really want the user to actually create an object of this animal class. So how can we stop them from doing that? Okay. To stop them from being able to create an object of a specific class, but still be able to have that class in code to then inherit, we can use the concept of what is known as an abstract class. An abstract class does not allow you to create an object out of it. So I haven't told you how to make an abstract class yet, but let's just say that this little a symbol means that there is an abstract class. If I make animal an abstract class, I can inherit all I want from it, but I can never make an object of this class. And by that I mean I can actually instantiate an object. And also, when I inherit from an abstract class, the derived classes are going to be by default also abstract. So I will have to do something to these classes to get rid of their abstractness to be able to make objects. So once I do that, once I get rid of them being abstract, that will still leave the parent class to be abstract. And that is how I'm going to make it so that they cannot actually make an object of the parent class, and they can only make objects of the children class. And the way that I'm going to achieve making a class abstract in C++ is with the concept of virtual functions. Now, virtual functions are useful for a lot of things. So this is just one of the uses of them, okay? So, virtual functions. Okay, so how do I, and by the way, if the definition on the book for the word virtual is, they talk about the binding, but they don't talk about, so I don't know, there might be a definition. You have to read the book and see. But yeah, virtual functions, okay? I'll show you how they work, and then we can talk about how to properly define it, okay? So what virtual functions allow you to do is they allow you to create a class, create a function within a class that you don't give it a body to. You just make the name. It's kind of like making a function prototype, but not actually defining what's in the function. And C++, of course, if you do that with a regular class, it's going to let it slide for a minute and hope that later down the code you actually make the body of the function. And if you don't, then you're going to get a very weird error, which a lot of you guys have messaged me, which is, well, I'll show you. I'll show you what that error looks like. It's just like undefined function and things like that. And there's no color coding in the error message. So here, let me switch over to that. So if I go ahead and say something like void foo, I don't even think I need to have a class like that. And I run this. I think if I don't call it, it's not going to complain. But if I do call it somewhere, it will complain. So you get these errors. So I'm sure you guys have seen these errors where there's no color coding, and it's just a bunch of weird things here. Temp blah blah blah. That's the object file. And then it says the name of the file here. It says the location of the file, within the file, kind of. And it says undefined reference to foo. And if I have a bunch of these, I'll just get a bunch of those errors, like, repeatedly. In fact, if I put the same one, I think I'll get the same error just twice. You see that? But if I have other functions as well, you see. And when you typically see that, well, even if you had something like if suppose you did this, and then somewhere down here you actually went ahead and defined the function. And by defining it, I put the curly brackets. If you do this, then you're okay. Right? But what ends up happening is typically people make a typo. They make that an uppercase F. And now they're like, what? Why is this not working, And then it turns out that it's because of the typo here, because you're defining a completely different function here, but you still have this undefined and you're calling it, right? So you run into this issue, I'm pretty sure. So basically, the reason for this issue is because C++ expects you to have a body of a function when you call it, right? And similarly, if we're making a class, you kind of get a similar situation. So if you have a class A, and inside you have a function called void foo, and then I go ahead and remove this, and I run this code, it compiles just fine, right? Even though I don't have a body to the function yet. If I make an object of it, compiles fine too. However, the moment that I try to, and I can even actually use the object. So like if I have an int x in here, I can even go ahead and say ax gets 10, and then let's make this public as well. So otherwise I'm gonna complain. I can run this and it's working. It's actually setting x to 10. Otherwise it would have given me an error. So here's the thing. You technically have it's not really an error, but you know, it might not be what you're trying to do, because the moment that you try to do a.foo, then it's not going to compile, and it's going to give you an error saying basically undefined reference, that same error again. Okay? And you know, yet again, if you were trying to define it outside the class, you know, and you make a typo, you make it uppercase foo like that, then you are going to well, if you do it this way, it's gonna tell you that there's no function declared there, because there isn't, right? Because of the typo. So I guess that one is a different error. But the point is that when you do this, now you're okay, right? Because you actually declared this function here. If you don't declare it, then you get this error. So C++ does not allow you to create a function and not give it a body if you're trying to call that function. It will slip away with being able to not have a body if you don't call that function specifically. But if you do try to call it, of course, it's going to complain, because it's like, what code do I run, right? And so virtual functions, basically, you can throw in the word virtual. I believe you can throw it before and after. Have a very interesting syntax. You put a 0 there like that. So you put the function name and you put 0 there. And whereas before, even if I didn't have the body, so like here, actually, I'll do a before and after. So let's leave this class like this, and let's just make another class right here. And for the sake of space, I'm going to put that there, and I'm going to put that here as well, so I can keep things very compressed. That way, it's all in the screen. Okay, so I got class A, and I got class B. Hello, don't come here. Okay, so yeah, class A and class B. Okay, and so basically, the only difference between class A and class B is that for class A, I'm going to leave that function undefined like that, and then as long as I don't use it, you know, the code will work just fine. However, for class B, I'm going to do the same thing, but, and as you can see right now, everything will be working fine as it is because I haven't changed anything, but I'm going to use the word virtual. I put the word virtual here. Actually, if I just use the word virtual and I compile this, already it's going to start to complain. So that is here. Oh. Would a good example of a virtual function be like print animal, because all animals look different in the base class, and print animal doesn't see the body because there's no animal yet to print? Yes, that would be indeed a good example of that. However, you could also achieve that without using a virtual, like I have it here. This function could be called print animal right now, and this would still be compilable. So really, in addition to making a function that you want to fill out later, you also want to stop the user from being able to compile and run the code when they're creating an animal object, okay? So here we have an error this time on the bottom. And the only thing that I made a difference is I added the word virtual in front of it. I can actually go further and make it what's known as a pure virtual function by putting a 0 after that by saying equals 0. And then this time, I am actually going to get the word abstract, which is what we were talking about earlier. So cannot declare variable B to be of type abstract. So this is how we truly make an abstract class like this. The other one doesn't compile, yes, but this is even better because then you actually get a more meaningful error when you're trying to compile this thing versus again getting the obscure error here. And so this is what is known as a pure virtual function. And what it does is it allows you to create a class. So if I remove this, will compile just fine. However, I can't create an object of that class. The moment that I try to create an object of the class, I'm going to get an error there because I have a virtual function. And I haven't really talked about why that is the case. Right now it's just kind of magic you're thinking, but I will talk a little bit about that. But to be able to talk about virtual functions, I'm going to have to turn to the book to talk about what binding is. And yeah, that'll be an interesting talk. So, okay, from there, let's go ahead and try to do with inheritance. So let's try to inherit class B. Okay, there goes on. Class. Call it class D that inherits from class B. And that is going to have an int y. So now suppose that I try to make an object of class D. That is also going to be abstract because it's inheriting the virtual function. So I'll actually get the same error as before. This time it's saying D. So what if at this point, you know, you actually, so this is like the animal, this is actually D for dog, you know, so I suppose this, let's, yeah, we'll say this stands for animal. So we'll make this animal, and this is inheriting from animal. Okay. And this is the speak function. So it's the sound that animal makes, which they all make different sounds, right? So, and this is their age. And then the dog has a leg count, although that could be shared between all the animals. Although not all animals have legs technically, because like they have fins or things like that. So yeah, we'll do that like that. Okay, and let's get rid of foo since I proved that point already. Okay, so now I still have an abstract class in my inherited class. So any class that's abstract that you inherit, if you don't do anything to it, it's going to remain abstract. So what do I do now to make it, to sort of undo it and, you know, remove the abstractness for it? Well, what you do is you just define the function that's virtual. So you have to define all virtual functions to basically get rid of the abstractness, which makes sense because you need a body for the functions. So what we're going to do is we are going to simply write void speak the same way that it's above, and then go ahead and give it a body. So, you know, it's going to wolf because it's a dog. And now this code will compile and run. Well, assuming that I don't forget the curly bracket, the semicolon after the curly braces. As you can see, it runs just fine. Furthermore, I can't make an animal class object. So I can't make like animal A. That will still tell me that it's abstract because that one is abstract. So what I've made now is I made that hierarchy where I have a dog and I have an animal, but I don't let the user make an object of the animal class, only of the sort of the final tier of the classes, the ones that are okay to make objects of. So let's go ahead and make a cat. So the cat is going to meow instead of wolf. Okay? And it also has legs, I suppose. So maybe we could have an intermediary class that just adds legs to it. So yeah, we'll do that next actually. So as you can see, this is working just fine. But you know what? I think that we should make a class that is an abstract class still, but it's called four-legged. You know, because that's going to keep all the four-legged animals. And all it's going to do is going to add a legs variable to it, but it's still going to be abstract. So because it's still going to be abstract, then I'm just going to inherit publicer from animal. And I will also make this public. Again, you can do protected and all that, but again, I don't want to have to type a bunch of getters and setters. So now I don't actually need this to inherit from animal, but from four-legged, because now I don't have to copy and paste this leg thing into multiple lines, into the multiple classes, because it's inherited. And I'm pretty sure there's more things that four-legged animals could share, like number of fingers and things like that. So yeah, and let's say that the dog has an extra feature, which is the string. What's the thing a dog has that the cat does not have? I don't know. Those are very similar, so it's kind of tricky to pick on that. So we'll give it a function called man's best friend, a soul. I agree. So void has soul, and the code it basically says yes. Actually, that is something that we could share between them in here. We could say virtual. Although before I add that virtual function, here I want to show you that this works fine. Well, God damn it, I always forget to put these things in here. This works fine, and I can make a dog. I can make a cat. That will work fine as well. However, I cannot make an animal. And I cannot make a four-legged object, which makes no sense because, again, which four-legged object is it? So here, let me first show you animal. That doesn't work. And then if I get rid of that and add the four-legged one, that one will also not work. Same error. Basically, I'm trying to create an object of abstract class. So that's kind of what I want. But now, you know, we want to check. We also want to add here another virtual function. Or actually just a Boolean. That's actually easier. Hassle. You know, and then we can actually just set it to true in the constructor. What does it say? Cats got whiskers. I don't know if have those. I think some dogs have whiskers actually, like a schnauzer or something. But here, I'll make this as a function just to show you that. So virtual boy has soul. Okay. So here's the thing. If I make another virtual function, this is already an abstract class, but I guess you could say it's a little bit more abstract in a way. But what really that means is that now dog and cat are still abstract because they inherit from four-legged, and this still has a virtual function that has not been defined. So now if I try to run my code, it wouldn't work. To fix that, I actually have to add in the hassle function. Now let me tell you something that it's interesting that it doesn't work, but I want to point out because if I don't show you this, you might actually run into this issue. Say that you're like, oh, you know, I'm just going to define the name of the virtual function outside by saying like a hassle, and then I'm gonna say cout yes, right? So I believe it's been a while, but I do believe that this will not work as well. Well, hold on, let me get rid of the cat for a second here, just so I can see if that's the error. So yeah, perfect. It doesn't work. So it's kind of interesting, but the only way that you can define the virtual function, and again, this is probably some compiler tier thing, parsing related, is you actually do have to write here the prototype, has soul, like that, well, soil. You have to put it here. And then you can define the function body like I did here inside, or you can do it outside, but you have to put the has soul thing in there first. Otherwise, it will not work. So don't just try to add this in your class. You actually have to add the function name that is virtual, that now you're making not virtual, in here, okay? So for this one though, I will go ahead and just do it inside because it saves me space. So that happened the last time I did 202. I think I never showed that version and people were confused. So I want to make sure that I point that out this time. I actually am not a fan of cats, so this actually is fitting. So is it still virtual even if you don't set the equal to 0? It is virtual, but you get that different kind of error if you don't do the it's equal to 0. You get the undefined function thing. That's just was up here. This one, undefined reference. So this is, I think this one right here is the undefined reference to B table for B. And this B table thing, we'll talk about that in a minute. Although really you talk about it more in detail in 226. Oh, I don't want to update. I've never updated this. It's like so old. So classes become abstract, but one of their functions is virtual, pure virtual. But yes, I suppose virtual as well, technically. Although, no, just think about it with pure virtual, because there are cases where I could get away with writing a virtual function and not make it abstract. Okay, so pure virtual. If you keep the second prototype inside dog and remove the definition, does it still run? You're gonna get that undefined. I believe you're gonna get. Oh well, no, you wouldn't. It would still run as long as you don't call the hassle function. So this will run. In fact, let's uncomment the cat one since that one is already set up. Oh no, it doesn't. Oh, I guess because it's a virtual and then you define it, but you don't give it a body, so you get that error. So yeah, stand corrected there. So it will not run even if you don't call that function, but it'll again give you that vtable error, as if you had made just a regular virtual function. So yeah, okay. So what is this actually doing? That's the real question. Like, why does this work the way it works? Like, this virtual thing is more than just a way of limiting people to not run code, basically. And it's gonna have to do a lot more when we're talking about casting. But before I go into talking about casting, let me try to explain what the book talks about when it comes to binding. And again, this binding stuff will be revisited more in detail when you actually get to 326. And yeah, 326 I think is when they'll talk about static versus dynamic binding. But I'm going to try my best to kind of give you a sort of an introduction into that. So you haven't really run into this because, again, we just learned pointers and we have used pointers very little with classes. But let me give you a sort of theoretical scenario here, okay? Which is also tricky to think about. So, yeah, okay. So let me give you a theoretical scenario, and then we will come back to the virtual stuff. Okay, so we're gonna call this we'll call this vtable. Let's suppose that we have a class A, and class A, you know, we don't really need to put anything in it, but we'll put a variable in, okay? And then we have a class B. Now let's make this public. And class B is going to actually inherit from class A. But it'll be a little bit interesting here, because now that we know about pointers, we know we can create an object of A by saying A, you know, PTR A, or APTR, you know, and we're going to say that gets new A, right? And by the way, I never showed you, so very, very quickly off topic, but yet on topic. Always make your constructors public, by the way, otherwise you get errors. But even if you have a, you know, if you have a constructor that requires parameters, you know, so like, let's say you're trying to initialize X. So we'll say this is, I don't want to have to deal with variable problems, so I'll just do that. Okay, so let's just say that you're doing this to initialize your class, right? And then you go ahead and you say new A, and maybe you set this also to 0, so it's a default. Let's make sure that this runs. Table. Okay. Class. Oh my God, why did I make them uppercase? Okay, so this runs just fine, but now if I want to pass in here like a 5, you know, this works fine too. So like, you can use custom non-default constructors also when you're dynamically allocating. Just go ahead and put the parentheses like this, okay? I don't think I ever actually showed you that, but I kind of assumed that you just tried at some point and be like, okay, it works, you know? Oh, we have questions. So I'm still a little confused about a class named animal, then I have a public dog. During the implementation, if I say animal, dog, string, what is the mistake? How do you fix that? During implementation, if I say animal, dog, string, what is the mistake? How do you fix that? I'm not sure what you're saying. Well, what I'm saying with the previous thing here is that I am able to create an animal class that has all the shared attributes that I want. And then the final sort of end user classes like dog and cat have only the unique functions associated to that dog or a cat. So it doesn't have anything that's shared. But it allows me to have these sort of intermediary classes that are not really meant to be, that you're not really meant to create objects out of. They're just there as sort of, like I said, intermediary classes. So like classes that you're making to save having to copy paste code, but that you don't necessarily want people to create objects out of, because they're not really meant to be that. So I don't know if that's what you're asking. Because animal dog, that doesn't really make sense when you're saying animal dog. Oh, it's related to homework. Well, you don't do virtuals in the homework yet, so don't get confused between that example. That is different, I think, the way that is done in the assignment. It has nothing to do with virtuals. So that just happens to have a class called animal, which you have an object called dog, but you're not doing inheritance in the homework. So that's totally different topic. So don't get confused. Don't think about the homework when you're thinking about this one. This is a totally different thing than what the assignment is doing. The assignment has to do with just, I believe you have an animal and you make different objects of the animal class. There's no inheritance involved. So that's why you can say something like animal dog, if I recall correctly. So we can come back to that. But anyways, let me show you this part. Just to clarify, to make a class abstract, the function within them must be declared as virtual. Yes, but you don't have to make them all virtual. Just a single function that is virtual, a single pure virtual function will make your class abstract. You could have 20 different functions in here, and if they're all regular functions, but one of them is virtual, then your class has all of a sudden become an abstract class. There's also sort of a jargon, because the thing is that the term abstract and interface play a different meaning when you're dealing with Java. So I guess that might be a good point to talk about that. So this is strictly a definition kind of thing, and no, they cannot be. You cannot make variables virtual. That will make more sense once I explain how virtual works, but you can't make them virtual. You can make a class virtual. You can do virtual inheritance. Well, you can do virtual inheritance. You can't necessarily make, I suppose, a class virtual per se, but you can do what's known as virtual inheritance, which is how we solved the diamond problem, which I kind of teased a couple of days ago. So, but you cannot make variables virtual, okay? At least directly. So, I forgot what I was going to say now. What was I saying? Well, I don't know. It's okay. But anyways, going back to this, I guess, since I can't remember what I was saying, is let me show you this, which will lead up into the sense of why virtuals are really created. Because I remember what I was talking about. Java with abstract classes. So Java has a different meaning for what an abstract class and an interface is. So if you know Java, you might be a little bit confused. If you don't, then hey, at least you're not confused. But you will be when you learn Java and you get different meanings of those terms. So in C++, the book specifically and in general, they use a very, very peculiar meaning for what an abstract class is and what an interface is, okay, in C++ terms. And this is strictly a definition sort of thing versus a practical usage thing. So it's good to know, so when people are talking about this, but it's not necessarily going to make a difference in your programming skills, I suppose. So there are two terms that I want to talk about: abstract class and interface. And again, this is strictly talking about C++ and not Java, because that's going to be different, okay? In C++, we consider an abstract class to be a class with at least one pure virtual function. As an example, here's one of them: void foo equals 0, like that. Okay, that's a pure virtual function. Okay, if you have at least one of those in your class, it is considered to be a pure virtual function. It's considered to be an abstract class. Sorry. You can have variables in there. You can have regular functions in there, and by regular I mean non-virtuals, and they will still be considered abstract if there is at least one virtual function. Okay. On the other hand, an interface, at least for the definition term in C++, we consider a class that only has pure virtual functions. No regular functions, so non-virtual functions, and no variables. And we call that an interface. And again, this is not like Java. I'm telling you that a couple of times, because if you go learn Java, then you're going to be like, he lied to me. No, Java is different. Okay. And yeah, that's all there's to it. So that's mostly like a definition kind of thing. So when you see a class, if your class is full of virtual functions, then it's an interface. If your class is a mixture of virtuals and non-virtuals, or variables in there as well, then it's an abstract class. Either of these you cannot make an object of. So cannot instantiate an object out of them. However, either of these you can make a pointer of, which is going to make things a little bit even more interesting. That's kind of the end game, actually. Okay? So, yes, we shall see that in a second. So if we go ahead and go to the code, let me tease that actually with this example. So if here I go ahead and say animal A, and let me compile the right one, it will compile. So you see that? So you can't make objects out of abstract classes, but you can make pointers out of them. And if you're asking yourself as to the why you can do such a thing, and why would you want to do this, because you can't make an object. I can't do this. I can't go ahead and say A gets new A. See, that gives me the error. A does not name a type. Oh, animal. My bad. What are you guys doing? What does it mean when you get a little timer there? I don't know. Oh, don't waste your money. You guys are cheering the bits. I feel bad. You're like throwing away your money at this point. You're getting scammed basically. But yeah. Okay. So yeah. So you can see there that I have the animal that I have created, and it is not letting me because it's abstract class. So where I can make a pointer of the animal class, which is abstract, I can't instantiate an object of it, okay? So this will come back in a second as to the why. But first, let's go back to our vtable example, because we need to understand truly what is happening here with virtuals before we can move on to talking about that pointer magic. So here we have a class A and a class B that inherits from class A, okay? And so now I'm going to create an object of class A called new A, okay? And that's called an APTR. I can prove to you that APTR does contain the data by basically saying, assigning it to something and then printing it out, okay? Yeah. Oh, I forgot to. Oh my gosh, I don't even have an include IO stream in here. And then I'll put using namespace, so I don't have to put std in front of everything. Okay. All right. So the 10. So the 10 is working, but this is where the fun begins here. What I'm about to do. Let's go ahead and add a function. Let's add a function to A. Let's call a function foo, okay? And that function is going to see out I am an A. Okay? And then down here in class B, I'm going to have a function called foo as well, that says I am a B. Okay? So right now, if I go ahead and say APTR foo, I expect to see I am an A printout. Okay? Good. Let's go ahead and make an object of B. So like BPTR. And that is going to get a new B, and we don't put a parameter in that one. Okay. So now this one if we go ahead and run this, it compiles. Let's go ahead and say bptr foo. I run that, and I get that I am a B, which it's correct, right? Cool. Okay, so now let's go ahead and make a pointer of A. So we'll call this another A. And let's make that another A point to the B. Okay, so I have a pointer of A type pointing to an object of B type. Another A like that. Let's do it like that so it's easier to see the other. Okay. Cool. So then let's go ahead and say another A foo. What do you expect this to print out? Because in reality, bptr is what's being held here. And bptr is a B, right? But we are pointing at it with a pointer from class A. So is it going to print out that it's an A or it's a B? And the reality of this is that it's a B. That's what we're really pointing to. We can prove it because, you know, I could store something in bptr. I can say like bptr y gets 10 or 11. Okay, so bptr is indeed a B, and it holds the variables from B, like the y. But it's also inheriting from A. However, when I ask what it is telling me that it's an A. Do you see how that could be a problem? Furthermore, you know, just to make things weird, let's make another B. And let's make another B point to the A that we have. So that's the other direction. In this situation, it doesn't even let us compile. So it's letting us go in one direction, but it's not letting me go in the other direction. I can, however, force it. There we go. And now I can go ahead and say another B's foo. And that prints out that it's a B, even though it's really an A, right? Because that's what we sold it. You know, it's what we put in it. Oh, sorry. That's why I was trying to make the code compressed. Let's put all these in the same line, and then let's get rid of this space here. And yeah, okay, there we go. So we got pretty much everything in the same line now. Oh, I think there's a free space up there. There we go. Cool. So I am going to go ahead and make a pointer of B and point it to a pointer of A. But that didn't compile, so I had to do some nasty stuff that I haven't talked about. But once I got that nasty stuff out of the way, and I will go ahead and run it, it told me that it was a B when it really is an A. So as you can see, this one, okay, it's not as big of a problem because I already had to do nasty stuff, which you wouldn't regularly do. This is a problem because this one I didn't have to do nasty stuff. All I had to do was make a pointer of the superclass point to the object of the derived class, or of the child class. And it broke it. And that's a problem. Okay? Do you see how this is a problem? Do you see why this is an issue? That we have an object that is of a certain class, and all of a sudden, just because we have it being pointed to from another object that is from a pointer that is of the parent class, all of a sudden the object is thinking that it is a object of the parent class. So in terms of pictures, because pictures always speak more than a couple of words, I think that's about 1,000 words per picture or whatever they say. We have our class A And that class A in memory has a foo and it has an X in it. And we have a class B that basically takes A and expands upon it, right? It's called B, and it basically has a foo, but it redefines it, so this is called as foo v2 per se, and it also adds an int y, right? So if I say b foo, you know, an object of B called just lowercase b foo, I am expecting to get b foo's b2 and not this one because I redefined the function. So it's supposed to be a newer function, newer, better function, right? Similarly, if I have an object of A and I call foo on that, I expect to get the base class as foo, not the B one, because it's not an object of B. This is really bad, actually, in the second case, because if this foo from the second one try to access the y in there, this would crash probably. Oh, it does not like this being in the same line. Okay. And then let's just do cd equals c plus 11. And then we run it. And it didn't crash, but it got some weird garbage value that is not what is being held in y. You see this? So this foo, you know, when it's a b, so originally we start out and say I am an a, and it gives us a 10. I am a b gives us 42 because that's what actually is contained in a real b object. This is incorrectly being classified as an a object when it's a b object, and this is an a object that's incorrectly classified as an a object, and it's printing out a value 0 from who knows what in memory. So that's even worse. Oh, wrong screen, omega low. Oh, there we go. So yeah, let's do that again. So let's see this again. So we are getting I am an A, which is coming from line 23. And then line 25 is I am a B42, which is correct because it's a B. But then lines 28 and 29 are making a pointer. Well, 27 to 29. 27 is making a pointer, this here, of A. And then I'm having it point to an object of B. And then I'm calling foo using the pointer. And I'm fooling the computer into thinking that it's actually an object of A when in reality it's an object of B. And that's very, very dangerous because if I try to see out a function from you know, for example, when I go ahead and do the opposite, you know, B has variables that A doesn't have. And if it's calling the wrong function from the wrong class, and I'm trying to see out some of those variables, I'm going to get garbage or potentially segfault. So like that's what happens in the last few lines. In the last few lines, I go ahead and make a B object and make it point to an object of A. And then I try to go ahead and call foo, and it is calling foo from B, even though it's an A, and because it doesn't have such a variable, and A doesn't have a Y, when it's trying to print out the Y, it's doing the arithmetic shifting to locate the variable, which in this case doesn't have anything, and it's getting me a 0. But it could just as well segfault or give me garbage. You know, it just happens to be that I'm getting a 0 here. So it's really bad. There's a lot of mistakes together. And this is really what we're trying to solve with virtual. So let me show you the solution, and then we can talk about the solution. So let's go ahead and write the word virtual in front of, I think maybe just this one will be okay. The base class. And now, all of a sudden, the problem is fixed. By putting the word virtual there, I fixed the problem. Let's look at it before and after. Here. So this is before, and then after. Okay, so The A and the B in the top are still okay because those are just regular. You know, we have an A pointer pointing to an object A who calls foo, and a B pointer calling to an object B who's B. Okay. However, before, when I didn't have the word virtual, if I have a pointer of object A pointing to an object of B, so an A pointer pointing to B, which is what I have here in line 28, then when I called foo, it was calling A's foo, when in reality the object is a B, not an A. When I added the word virtual, all of a sudden now it knows. It just knows that it actually, even though we are pointing at it with a pointer of A, it really knows that in the reality it's not an A, it's actually a B, and it's calling the correct function. And similarly, if we do the casting here to make a B pointer point to an object of A, it still knows that it's actually an A, and it is calling the right function at the end. So no longer we're calling the wrong function and some invalid data. Even though you don't know, again, I haven't talked about why this works. Do you see the difference between before and after here? Do you see how before we had a problem where it was calling the wrong function, and now by adding this magical word virtual, we fixed that problem? Do you see that? At least do you see that much? You know, the next part will be me trying to explain as to why this works. But before I explain, I want to make sure that you see what we just solved. Yes. Okay, cool. Great. So let me drink some water and then try to explain this. So the reason why this works and the reason why we have that problem is because of how compiling happens in C++. So looking at the book, and if you're curious, this is on page 860. We can see here, and I guess they're doing it. Yeah, they kind of do this. I'm assuming they do some sort of similar example in page 859 to kind of what I did, where they have the functions calling the wrong class. I'm going to assume. I haven't read that in a while. But if you look at the bottom of the page, it says, more specifically, in compile time binding, the necessary code to call a specific function is generated by the compiler. Okay? And so what does that mean? Oh, and I suppose I should say something up here. It says C++ allows the user to pass an object of a derived class to a formal parameter of the base class type. So that's interesting. But anyway, go back to this. So in C++, when you compile your program, there's a connection made between the member functions and the class itself. Okay? So this is known as compile time binding, or also as static binding or early binding. So let me write some of these names down. It's important. But again, they will go into detail about this in 326. Okay? So hopefully you get it now. But if you don't, they'll really hardcore nail it in that class. Or at least they should, allegedly. So C++, thus what is known as basically as compile time binding, also known as static binding or early binding. Now what this means in layman's terms is that functions are associated to a specific class. You know, if you think about it this way, all objects have their own variables, right? Unless they're a static object or static variable, you know, that one is shared, right? Remember we have a bunch of objects and we have one static variable, they all share it, right? We talked about that. However, each object has its own copy of variables, right? They all have their own copy of variables. However, when it comes to functions, it's kind of pointless to have a copy of the function code inside of each object. It's just a waste of space. So really, somewhere in the computer, somewhere I guess in your program's code, you only have one copy of the code of a function. So we have a foo here, and when we have a bar, and we have maybe foo2, foo v2, and so on. Okay, and they only have one copy, and then and this is again to save space. But then what ends up happening at compile time is that inside of these objects, so let's say these are all animals, you know, or whatever. Just, actually, no, don't even think about that example. Just these are all objects of the same class. We'll call this class A. Okay? And class A happens to have a function foo in it. You know, that was part of our definition of the class. And so what is happening is this writes down the word foo, but it doesn't actually write down the code. It just makes a reference to it. Think of it like a little pointer. It has a little pointer that references the beginning of the foo code. Okay? Then, if you go ahead and do inheritance, and then redefine a function. So let's say that I inherit class A into a class B. And class B has the same variables as A, and they all have a copy, but then maybe I add other variables in it. And then I redefine the function foo. If I don't redefine it, then it still references that one. But I redefine it by giving it a new body, as I did in the example I showed you, and I make it a new version called foo2. And so at compile time, the compiler just keeps a reference to the right function. And this is done to save space. Okay? And it is done at compile time. Okay? So, this causes a problem in what I'm doing, because when the compiler is looking at the code and it sees the line of code that has something like, so if I have an object A, you know, or actually let's say I have an object of B called B, and then I make a pointer of object A, and then I make A point to B like that. You know, in this case, I'm not using two pointers. One of them is actually a static object. And then I go ahead and do a foo. The compiler, when it's looking at this line of code, it doesn't know at the time that foo is really an object of B. All the compiler sees is that you're calling foo on a pointer of A type. And because it sees that it's a pointer of A type, it just assumes that it's going to be a function called to A. So when it's doing the binding, it keeps track and saying, by the way, make sure this line of code calls this function. And there lies the mistake. Because it doesn't know. Because it doesn't know. I mean, you might be thinking, well, why doesn't it know? Here I'm doing this, ampersand B, and I know that B is a B. Yeah, no, the compiler can't see that. It's not smart enough per se to see that. Because it doesn't really know what's happening in memory. You know, all it sees here is it sees it sees that you have an address and you have a pointer variable, and it's going to copy that address. And while it's going to check to make sure that that is the same, you know, hierarchy, you know, it doesn't see anything beyond that. And so because of that, with static or early binding, when you're doing runtime stuff, it's not going to be able to call the right function. The solution to this is to basically, some programming languages use what's known as runtime binding, like Python, or pretty much any interpreted language, actually. So runtime binding does the function association at runtime. And when I say the word runtime, I'm saying when your program is physically running, like when it's actually running, not when you're compiling, but when you're running it. What does that mean? That means that when it sees this line of code, it doesn't care what is here. It doesn't care what that pointer type is. All it knows is that it has to call foo of the whatever this really object really is, which and then it really sees that it's actually a B, because it knows that, because it's been running the code right beneath before it. So it's actually aware of what is happening. Runtime binding is, we shall say, less safe than compile time binding or static binding. It's less safe, but it gives you more flexibility. And like anything in this world, there are pros and cons. C++ is very strict about what you can and can't compile. And the idea behind it being so strict is to protect you from making mistakes. On the other hand, with runtime binding, it's a little bit more YOLO in the sense that, like, it just assumes that you're not going to make mistakes. So there's more flexibility at the cost of less checking at compile time, which means more risk of errors happening later on in the program that you don't catch early on. Another name for dynamic binding, by the way, is just or another name for runtime binding is actually dynamic binding, which is kind of the opposite of static binding. Dynamic binding, and there's also another one which the book says is called late binding. All three mean the same thing. Okay, so all three mean the same thing, just like static binding, early binding, and compile binding all mean the same thing. They're just different names. Okay, so I guess you could say compile time and runtime. You know, those names sort of kind of match. Static binding and dynamic binding, those kind of match. And early binding versus late binding match. It's kind of like saying parent-child, superclass and derived class, or base class and derived class. And yeah, so just different names for the same thing. Okay, so we got a question. Is when the compiler identifies the type of object at runtime that matches the function call with the... Are you asking a question or are you answering something? When the compiler identifies the type of object at runtime and then matches the function call with the correct function definition. When the compiler identifies the type of object at runtime and then matches the function call. Yeah, so that is going to be dynamic binding, what you're asking. What you're saying. That is dynamic binding because it identifies what the object really is, which you can only figure out at runtime when the program is actually running. And yeah. So I guess what you're asking is what you're saying is the definition of dynamic binding. So yes. So yes, it's just there's probably a delay in the messages. So I get messages delayed, and so at that point it's like be out of context sometimes. So it's okay. But anyways, yeah. So basically, if you're doing that association of the function to the object at runtime, when you really know what is actually stored physically there because you're running the program, then you're good to go. Now, why can't you do this sort of checking when you're compiling? Well, let me put you a scenario where you wouldn't be able to do that. Suppose that I had an if statement. So let's comment all of this up. And I said something like, let's make an object of B called BB. And let's make an object of A called AA. And then let's make a pointer of object A, PTR. And now I am going to see in from the user a value. So I guess I'll make a Boolean called answer. And we'll set it to false. Okay? So now I'm going to say cin answer. And I'm going to say if answer is true, basically, then I'm going to go ahead and make PTR point to A. Otherwise, if the answer is false, or if the answer is 0, then PTR is going to point to B. And after I do either of those, then I'm going to go ahead and call foo on PTR. So now, if I said I'll give you $1 million if you tell me which food's going to get printed, and you take that bet, then you have a 50% chance of losing, or 50%. That's pretty good odds, actually, but it's pretty bad because you don't know. It's impossible for you to know at compile time what PTR is truly pointing to, if it's A or B, because it depends on user input. Like if I, and here, I can show you that. Right now that I have virtual and this will actually work correctly, we can see that happening. Oh, this is also an ampersand here because it's our static objects, not dynamic. So if I run this and I put in a 1 for true, I get an A. But if I run this and I put a 0, I get a B, right? So the point is, at compile time, it is impossible to resolve what I'm pointing to. In the other one, yeah, you could kind of say, okay, you can see it there. But here you can't. So here it's impossible, no matter how good you are as a programmer, to make the next generation of compilers, it is impossible for you to do compile time binding and be able to bind it to the correct thing because you don't know, right? With runtime binding or dynamic binding or late binding, whichever name you pick, you can't do this because you're going to wait until compile time, or sorry, after runtime, when you really know what is actually being stored there, and then call the right foo. And how will you know? Because you'll see which line of code you ran. If you ran this line of code or you ran this line of code, you'll see what it's actually pointing to. So that's a more practical example so that you can see how it's impossible for us to figure out which foo to call. We can't decide that ahead of time. We have to wait until runtime. And so even though C++ does compile time binding, virtual functions allow us to do runtime binding or dynamic binding essentially. And that's why adding the word virtual fixes this problem, because it basically adds this to what is known as a V table, which is basically a list of potential functions that could go either way. You could define it to be that, and then it says we'll wait until runtime and then figure it out. Now this can cause problems though, because if you're doing something you shouldn't, like you're casting something to something that you really shouldn't, you could run into more problems. So again, it adds more risk it gives you more flexibility at the cost of a higher risk of creating an error, which typically leads to a segmentation fault. So that is really how virtual actually works. It is allowing you to do dynamic binding, runtime binding, late binding. Okay, it is basically putting your function in a virtual table, which is called a V table, which is sort of on standby, waiting to see what the object really resolves to before calling it. Okay. So basically, as the book says, more formally, in runtime binding, the compiler does not generate the code to call a specific function. Instead, it generates enough information to enable the runtime system to generate specific code for the appropriate function call. So that's the book's explanation on that. So hopefully this makes sense. And now we can actually go back and talk about as to the reason why this will actually this whole abstract solution thing actually works. And that is because when we're making this an abstract class, we're telling the compiler that this virtual here, it's not a function that we're going to define right now. It's going to be defined later, and so it basically does not allow you to create instantiate an object of that, because it wouldn't be able to resolve it, because in your V table you don't have a speak function there. However, when you go ahead and make an object of dog or cat, and there is a speak function here, that is held in the B table, and that is going to be done at runtime. So I can create an object of animal here, a pointer of animal, and then make that be referenced to like a dog, for example, which I guess I put a B for dog. That's weird. Let's make it a D. And then I can say dog speak, or sorry, I don't like these uppercase variable names. So we can say a speak, and that will actually call wolf. Wolf. However, if I change this to the cat, then that will do meow. And that is also runtime binding, because I made it a pure virtual function. So that's the reality of this. Is, I guess, a bonus that we get out of virtual functions, that we can do this. But the real purpose of them is actually for the ability to have dynamic binding. So that's what I really want you to understand. And again, as to how internally this whole vtable stuff works, that is the ferret to 326, which is called programming languages, and they will break down and spend like a month talking about the if statement and like the dangling else problem and things like that. And then they'll spend another month on like loops, and then they'll spend like 2 weeks talking about virtuals and stuff like that. So they'll really look into the why things are done the way they are in programs. So that's gonna be kind of like the culmination of you learning. You gotta first learn how to program so you can actually really start to analyze as to why things are programmed the way they are, right? Like, why do we have if statements that are formatted the way that they are? Why don't we make them be backwards? Put the else before the if or some weird thing. I don't know. They'll really look into that into detail. So yes, it's a cool class. So How do we feel about this now? Now go ahead and ask more questions now. So if you want to go back and talk about the assignment, I guess, about the thing, I can try to open the assignment. But this is what I really wanted to get out first, because I'm gonna put out an assignment, and I want to make sure you guys can do it. So yes, I do have one more topic to talk about today for the day though, which is up and down casting, which I already kind of did, but now I'm gonna define it by name and talk a little bit about that. But if you have questions, feel free to ask them now as well. So I don't know how big of a delay. You can see how much of a delay it is, because when you write a message, you can see how long it takes to show up here, and then for you to see it, and that'll tell you the delay that there is to your messages. I guess I could talk about the diamond problem solution. Remember the diamond problem as well was where you have a class, and then you have a class A, and you have class B and class C. So and then you have D, which kind of like inbreeding, right? And are we allowed to use virtuals on the assignment due Friday? Which assignment is due Friday? Is that the string assignment? If that is a string assignment, then yes, you can use them. Also, you can use them in the assignment in the other one, in the one where you're making assignment 1 again. So yes, you can use virtuals in either one, I guess, that you currently have out there. You can use virtuals in any assignment pretty much. It's normal. It's normal to lose. That's a hard assignment. It's normal. That's why you don't want to leave it first. The subtraction is easy if you do it systematically. And by that I'm saying you basically need to just think about how you did the searching in the first assignment with the Twitter stuff. Because you did that. You can take that piece of code that you did to search, and you can use that to remove text. So if you remember, in assignment 1, you were able to search a string for a piece of a string, for a substring, right? So you were able to like have some text, and then you had some key term that you were looking for, and you basically scanned the text, and if you found a full match, then you got back out of that a true or something, right? But furthermore, what you can do is you can get back an index from that as well. And if you get back an index from that, that's just going to be the index of the character where the match starts, which you can do because it's just a for loop. Okay? No, you don't even think about it in terms of vectors or arrays. All I'm saying is, when you were doing assignment 1 and you were doing your string matching for the tweets, you basically had 2 for loops, right? And the outer for loop was basically for the tweet, and the inner for loop was for the word that you were looking for, right? And so basically, if you found a match, then you would look at the variable here that you're using, the I. And you can return that I, if you have a match, as the location of what you were looking for. And why are you doing this? Because when you're subtracting, the first thing you gotta do is you gotta find if there is anything to subtract. And how you do that? You find out if there's a match. So what you need to do is, even if you did it with bool, is you just need to keep track of these variables. So maybe declare them outside, declare your I and J outside, and that way you just initialize them here, but they're declared outside. That way they're accessible outside of the loop. Well, yes, that which is what you should have done for assignment 1 is just a nested for loop. I would use for loops and not while loops, but yeah, you can use a while loop, but essentially it's a counter-based thing because you're just traversing through the text, and you know how big the text is because you can use size, which is a function in this case you'll have to make instead of having it available to you. But that's easy, right? You somewhere you have to keep track of the size anyways, so it's just a variable. So yeah, so once you find your match, then you can proceed to removing it. And the way that you can do that is, if you know that the word you're subtracting is 3 characters long, and you know that, let's say the message where you're going to start subtracting starts at index 7, then you know you got to remove index 7, 8, and 9. So write another for loop that basically copies from 0 to 6, and then from 10 to the end of the string. And there you go. That is how you subtract. So again, it's basically assignment one's search function with a little bit of extra. And that a little bit of extra is just merely, instead of returning a Boolean, return the index of your for loop. Because that tells you exactly where you start searching. So just return that index, and that's going to get you the starting point. And then just see how big the word is that you're looking for, which you already have in there, which is just the word size. And that way you basically add that to the index. So if you get the index back saying that it's 7, and then you know the word size is 3, that means that the characters you got to remove are index 7, 8, and 9. And then you can write a little for loop that just copies it into another string, and then, well, your string, and then skips those when it's copying. So you can write an if statement saying if I is equal to 7, 8, or 9, put a range, which is the math that you do here. So if I is greater than, and let's say this 7 is x. If I is greater than x, and I is less than x plus n being the size of the word, then that's going to be basically the stuff that you don't copy. Otherwise, so the else clause of this, then you actually do copy. So it's just that. So I know it might seem like a lot, but you got to really break it down into tiny little pieces and solve those. Like get the subtraction working, get the addition working, and so on. Maybe you're not doing deep copy. Maybe you're doing shallow copy, and that could be the why. In last lecture, you mentioned a way to resize a dynamic array by creating a new one with more elements and then getting rid of the old one. Do we need to do that for the operator overloading assignment? Well, I would say that you can pick a fixed size for the operator overloading assignment, because you can just say your strings can be a maximum of 256 characters. And that way you just not have to worry about that. I mean, it'd be nice to have a resize function. I don't know if I asked you for one. If I do, then you still got to start with a fixed size. So I would pick a big number and then just go with that. Anything else? Hopefully I answered your questions. In the meantime, let me see in the book the definition they have for up and down casting. Oh, interesting. So they call the slicing problem. The slicing problem is kind of what we were running into, that I was saying that when it was calling the wrong function and it was calling variables that don't exist in that class, I guess the definition for that is called the slicing problem. So interesting. Yes, there's virtual destructors as well that we want to talk about. So those we will probably talk about next time. Are we going to review what will be on the midterm? Yes, we will spend the last 10-15 minutes to do that. So I need to put in the to-do list here virtual destructors as well. And we can do the example of virtual inheritance. So I will put that down for next Monday. Let me write that on a notepad file. Virtual destructors and virtual inheritance. Okay. And that will be a good review of that. So, okay. Virtuals will not be on the midterm since we're just covering them today. But anything before that, yes. Okay, so let's go ahead and finish the lecture for today, and then we can go back and talk. We can go to the review. So as you can see, and I guess we won't really get to this pointer today. That's okay. We'll do that next time. So this pointer, okay, I'll put that there as well. So that pretty much gives us enough to talk about next time. Okay, cool. So let's talk about up and down casting, which we already did. So really, we're not teaching you anything new right now. I'm just kind of defining something that we already did into what it's actually called. So if we have a class A, and we have a class B that inherits from A, like that, I've been showing you that you can do something like APTR, you know, which is a pointer of A class, and then I could have a BPTR, which is a pointer of B class, and also can have objects of A and B, like actual objects, right? Which can be done either using a pointer or using a, or just like static objects, right? Like that, okay? So A is an object of A, B is an object of B, APTR is a pointer of type A, or we call it an A pointer, and BPTR is a B pointer, okay? So the act of me doing the following line of code which is taking a B object and having it being pointed to by an A object, you know, what I'm doing is I'm telling the computer, like, yo, I have this object of a derived class that I'm going to be pointing it with a base class. And as I have here in tiny little letters, because I always get them personally confused, is downcasting is what we just did. Or sorry, I failed. We just did upcasting, actually. So here, let's copy these down. It's kind of hard. It's kind of tricky to mess this up. You know, I'm glad I'm not the one taking the test, right? So yeah. So we got up and down casting. So we know that we're casting from 135, you know, casting an integer to a double and things like that. But we can also cast pointers, right? And that's actually what we're doing here. We are casting a pointer. Now here is technically coercion, because we're not being explicit about it, but we can be explicit about it. And so, which is the other part that I want to talk about. So here we are taking an object of B, which is the child class, and we're converting it, or at least we're making a pointer that is of A type, which is the parent class. So that is called upcasting. And you typically will get an error if you just flat out do it in C++, because it's very risky thing to do. There are ways around it, which I did. I use Reinterpret, but you typically will get some kind of error if it's because here's the thing. B has everything that A has because B is inherited from that. However, I said that backwards. This is perfectly fine. This is perfectly fine to do. It's the other way around that's dangerous, okay? So this is perfectly fine because what I'm saying is limit what functions I can call on B to the functions that are only existing on A, which is fine because everything on A is on B. The one that's a problem is this one, BPTR A. This one I'm taking an object of A and I'm making it into B. So I'm taking a parent object and I'm making it into a child object. And this is downcasting. This is the one that causes more problems, and it's not allowed in C++ by regular. Because, okay, the reason why this one causes issues is because A has a certain number of variables, right? So let's say this A here has an int X. And this B has an int Y. So if I ask you, how many variables does B have? You're going to answer that it has 2 variables because it has an X and a Y because it inherits, right? On the other hand, A only has 1 variable, and that is just X. Okay? So if I am saying to treat an A as a B, I'm saying take this A which only has 1 variable and treat it as a B which has 2 variables. And if I treat it as a B, it means that I can go ahead and access variable Y by saying BPTR_Y. However, that's an error because BPTR, which is really pointing to an object of A, does not have a Y. And that would cause a problem. In fact, it when I was running it earlier, that's when I got the 0 instead of the 42. So downcasting is a problem, and typically you can't usually do it. However, there are exceptions that are very popular and very common where you should do it. And so I'll show you examples of that. Okay? Upcasting on the other side, that one is perfectly fine. Because there you're casting from a child to a parent, so you're going back, which means you're just removing the ability to access Y. But you still have X, and it will have an X because it's derived from that, so you're okay. So upcasting okay, downcasting risky. However, suppose that in this line of code I have APTR, which is an A pointer, but it's pointing to a B. So suppose that I want to switch it back to pointing to a B. I could have BPTR get APTR. Now this is technically downcasting because I am taking something from a parent and making it into a child. But this one is okay because APTR is truly a B object. It's just that I was keeping it in an A pointer. So downcasting can be okay as long as what you're really holding there was actually something of the child and you just temporarily casted it up. Now you might be thinking, why would I do something like this? Why would I have a child object, cast it to a parent, and then cast it back to a child object? Like why? Why not just keep it as a child object pointer? Like why go through all of this mess? And the reason why is polymorphism and all these fancy terms. Because now imagine that you have an array of pointers. Okay? Here's the thing. CS135. Can you have an array with different data types in it? Or do they all have to be the same data type? Can I make an array that has both integers and doubles? Must be same. Oh man, there's a big delay. There's a big delay in this. I think you guys are responding to something that I said like a minute ago at this point. Oh, I see. You guys are saying same. Okay, so there isn't a delay. I just didn't understand how you guys responded with the same. Yeah. So yeah, they all have to be the same. They all have to be the same data type. They have to be what is known as homogeneous. Okay, like milk. Milk is homogeneous. There's also heterogeneous or heterogeneous, which is like orange juice, where like if you leave it standing, it splits, right? So arrays are a homogeneous data structure. However, using pointers, you can get around that. And you can make it out of everything you want in it. So that we will really get into detail also next time. But I'm going to show you one basic example here, which is super powerful when you're programming. And that is, suppose that you want to keep an animal farm. Okay? You got your dogs, your cats, and all of those things, right? They're different objects of different classes. You can make an array of dogs. You can make an array of cats. But you can't make arrays of dogs and cats. Or can you? And the answer is yes, you can. And you don't actually get to have to package for that one. That one is good to go. Because here's the thing. What do dogs, cats, and cows and all these things share in our program? And that's they all come from a base class called animal. So I could make this array an array of animal pointers. And then, if I want to store a dog in there, all I have to do is upcast a dog into an animal, which I can do. That's no problem. Yeah, that's what I was doing kind of here. I can upcast a child. I can cast a child to a parent. I can upcast it, and then this thing will have no problem storing a pointer of A, because it's an array of animal pointers. However, the rules of C++ don't say about what we're pointing to. It just says that the array itself has to be the same pointer type. Animal pointers, sure. But in reality, we're not pointing just to animals. We are pointing to derived classes like dogs and cats. And so if I want to store a dog in there, then I just have to, suppose that D is a dog, it's a dog pointer. Then I can just say, and this array is called R. Then I can just say R1 gets dptr. And then let's say that cat pointer is in cptr. Then I can say R2 gets cptr. And I can store both dog and cats inside of my little animal array without a problem. And they're different types. However, this does pose a challenge. When the time comes to actually access the data in here, all I see are animal pointers. So how do I know who's a dog and who's a cat? I gotta cast them back up. But if I try to cast a dog so if I have a dog who I upcasted into an animal, and later on I'm trying to cast this back to a cat this time, that's a real problem. That's a serious problem, because it's not a cat, and you're gonna get so many errors. You're gonna sec fault, and you're gonna be crying all day. You want to cast it to a dog. So how in the world am I gonna figure out what it truly is? Well, you can create a virtual function that is shared, that is called who am I. Yes, that is indeed how cat dog happened. Indeed, they casted it up to an animal, and then they were casting back, and they didn't know what to cast it to, so they just cast it to the wrong one, and you got cat dog. We don't want a cat dog. Cat dog was cool, but he's unique. We don't want to make more of him. So that's an old show, by the way. So what you need to do is you need to have a function that identifies what they are. Something like a foo, which we can call who am I. And then that can return a specific message or a specific integer variable or something that tells us what they are. So maybe you can return a 1 to represent a dog and a 2 to represent a cat. And I'll show you this in code next time as well. But you can basically return a 1 or a 2. And that way, once you find out with an if statement what that is, then you can cast it, you can downcast it to the right category, because then you know if it's a dog or a cat, right? However, if you don't use the word virtual and you were doing this, you'd run into the problem that we ran before, where it's calling the wrong function because it's done compile time binding. So we have to use the word virtual to be able to actually have it reference to the right function at runtime. And so that's a big power of virtuals that we have. And that is also what is known as polymorphism, because you have one thing that has multiple shapes, multiple forms, but it allows us to basically have our code to be very flexible. So I'll define polymorphism in a more formal term next time as well. But that's kind of what we're looking at. And this is when things get really cool with code. And you can do lots of really, really cool things with pointers and casting. But just to make sure, what for now I want to make sure you guys understand is up and down casting. And I get them mixed up, but I'm not the one being put on the spot when I take the test. But at least the test is open note, so you can actually remember which is which. But upcasting is when you have a child and you're casting it back up to the parent. Downcasting is when you have a parent and you're casting it down to a child. So in our example, if you have a dog and you're casting it to an animal pointer, that's upcasting. If you have an animal pointer which you want to cast back down to a dog, which hopefully is okay to do, because you're casting it in sort of the example that I gave, and then you're just casting it for fun, then you should be able to cast it okay. But it's far riskier to downcast than it is to upcast, because upcasting is always okay. You can always cast a derive into a parent because it will have everything. You can think of it this way. If you think about like this is your parent and this is your derive, the derive has everything in here, whereas the parent has this. So when you're casting up, all you're saying is you're losing access to this much, which is this stuff. But that's okay. On the other hand, if you're downcasting, you have a parent who now all of a sudden has all this stuff in here, but it really doesn't. It doesn't have these variables. It just thinks it does. And if you try to access them, bad things happen. So you really only want to do downcasting when you're dealing with an object that is being held in a pointer of a parent. So like the example here. So if I have an animal pointer, but I really know for sure that it has a dog in it, then I can cast it back down to a dog. Because if I don't, like you said, I will end up with a cat dog. So yes, that's the long spiel about up and down casting. And there is a way to somewhat error check whether the casting went right or wrong. And because again here, yeah, we're actually doing coercion because we're not explicitly casting. If you want to explicitly cast one of these lines, so for example, let's say we want to do the APTR to BPTR. If you want to use casting instead of coercion technically, then this line of code would become APTR gets, there's 3 castings that you can do, and we'll talk about them next time as well. There's static cast, which means if we're making this into an A pointer of B, that's one of them. The other one that exists is called dynamic cast. And then there is Reinterpret cast. So let me put those in here. Dynamic cast And you saw me use Reinterpret cast earlier. So what are these casting methods? And that's the last thing I'll say, and then we'll switch over to the review. Static casting is the one that you've been using so far. That's the one like in C when you do something like this. You know, that's the C version of static cast. It's a very safe cast. It does all the type checking to make sure that it's a valid cast. Dynamic cast does some checking as well at compile time, but it also does additional checks at runtime to make sure that you're not doing some mistake. You're not casting a dog into a cat and things like that. What happens is when you do dynamic cast on something that is a bad thing, because all of these would return to me addresses in this scenario. You know, they're all going to return to me pointer addresses. Static cast, you know, will catch the errors at compile time, but there are some errors that could slip. Dynamic cast does almost the same level of checks as static cast, but it does additional runtime checks to make sure that the cast is okay. And if it finds something bad at that time, then it will generate it will instead of returning to you the pointer address, the same address here but casted, it will generate an error by basically returning a 0, a null. So if you do this casting and then you check what, you know, if APTR is equal to null after you run a dynamic cast, then and you see that that's equal to 0, then you can generate an exception at that point because you caught an error. So dynamic cast will not cast if there's a problem at runtime, and instead will just give you a 0 back. Now you got to be aware of that, because if you just think that it casted and you start using this, then you're going to get a null pointer exception. Finally, we got Reinterpret cast. Reinterpret cast, when it comes to casting with pointers, is what I tell people as the YOLO cast, because it does no checking whatsoever. It's like YOLO, you know, you're doing the casting, it's on you. Good luck, have fun. Don't come back at me and cry when your program crashes kind of cast. It's useful for doing some nasty things like accessing private variables and doing some hackish stuff, but it's very, very dangerous. Okay, so you have to use it wisely. It's like, you know, great power comes great responsibility is kind of what applies to Reinterpret cast, and that is why you're going to be using it when you do the Crack the Vault assignment, which is the one that I'm going to be releasing probably next. So yes, we will talk more about them next time. So I'll put that on the list of things to do. So I'll give you examples of dynamic and Reinterpret cast, along with polymorphism and array of pointers of a base class. That'll give us pretty much everything to do on Monday. So that'll be Monday's job. Be a really cool class, actually. So now, that concludes. Can I explain the differences again? Yeah, so static cast is a typical cast you've been doing so far when you cast an integer to a double and things like that. And it does compile time checks. Okay? Think of like compile time binding, compile time checks, all happens at compile time. Runtime, if somehow you manage to cast something to compile code that compiles with static cast, there will be no additional checks done at runtime. Dynamic cast, as the name dynamic implies, just like with dynamic binding, it means that there's checks done at runtime. So in addition to having some static cast checks, so like compile time checks, it will have extra checks at runtime that ensure that the downcasting you're doing is okay to do, or any sort of other casting that you do, but typically it will be downcasting. So that's going to basically give you a 0 if you have a dog which you cast to an animal, and then you try to cast it back to a dog, that's okay. But if you have a dog that you cast to an animal, but then you try to cast it to a cat, if you do that with a dynamic cast, it will figure that out. It'll be like, what the heck, this guy's trying to put a dog into a cat. And instead of returning to you the pointer, it's going to return to you a 0. So now APTR will have 0 in it. And if you check that, you can see that it has a 0 and generate an error. And if you somehow try to access something from APTR, then you get a null pointer exception because it's just a 0. So it will return to you a 0 instead of returning to you the pointer, which is very good because you can error check that. Finally, Reinterpret cast is YOLO cast, as in like it does no checking. It does a little bit of checking in compile time, but like microscopic. And with pointers, it does 0 checking actually. And then at runtime, it doesn't do any checking, and it's essentially the we'll let you do it. It comes from the C standard. In C, you have void pointers and things like that, which basically allow you to cast anything, free-for-all casting. So that's kind of a sort of a remnant of that era. And so Reinterpret cast is like a cast whatever you want and hope that you're not doing something bad, because if you are, you're probably going to crash, but it's not my fault. So it's the It's a free country cast kind of thing. So, yes. Unrelated question. What happens if you reach more than 10,000 points? Will it crash or continue to accumulate? I don't know. I think it will continue to accumulate. I'm sure there's people here on Twitch that are hardcore and like have like 1 billion points or something like that. So, yeah. So, anyways, that's answer to that. So, that concludes today's lecture, and now we can talk about the exam. So let me go ahead and open the exam on another screen that you can't see. Don't try to do some forensics and like look at my glasses and get the reflection to try to get the answers. Okay, and here we go. No class tomorrow, just a test. That's right. So the next time we'll see each other will be on Monday. Well, you'll see me because I don't see you guys. Sad emoji. But yeah. So yeah, there will be no class tomorrow, and the test will be during regular class time. So I mean, I assume that I will be awake at the time, so I'll be on standby. So will the TA. But you just do the test, you know, do the best you can kind of thing. So the test is going to be a mixture of short answer questions and programming. Short answer questions you can expect. This is not one of the questions, but this is one from thinking from like 135 level. You know, in 135, I could ask you like, what are the 3 available loops in C++ and explain the pros and cons of them, or what they're used for. And you would say like a range, you know, you have range use for loops and also regular for loops, and they're used when you're doing counting. You know, you want to count-based looping. While loop is a event-based looping where you stop when you hit a certain event. And do while loop is a variation of that always runs at least once. So that would be kind of like the answer that I would expect. Concise, short, to the point, moving on. That way you don't run out of time. My test 1 review was hilarious. Well, I mean, that's what a review, I mean, what do you want from a review? I can't just tell you the answers. I can tell you what the topics are. So, yeah. Actually, wait, are you talking about it in maybe 135? Because I don't remember posting a review for this test. So I guess I'm assuming you're talking about CS 135, but otherwise I have no idea. But yeah. So you're gonna have questions, for example, that are gonna give you pieces of code. For example, there'll be a class, and there'll be a main, and then I'm gonna ask you to define a function. Okay? And I'm gonna ask you to basically define a class function, and then also define a class function outside of the body. So you need to know how to do that syntactically. Okay? I could ask you things such as like, when does a destructor run? You know, those kind of things. And then you should know. I may ask you to compare 2 different things like inheritance and composition. Okay? So the topics, again, are going to be basically everything up until yesterday, which is essentially boiling down to function overloading, object-oriented programming in the sense of what classes are, the difference between a class and a struct. Then from there you can move on into talking about inheritance, aggregation, and how you use those. What are the differences of when one applies and the other one applies? You can pretty much expect that to be on the test. And then from there we talk about dynamic memory allocation in the sense of what is a pointer, what are these different operators for, like the address of and the dereference operator, when do you use each of them. You have now the arrow operator as well, so like convert this code that uses an arrow operator into a code that doesn't use it, or vice versa. And then from there we're gonna talk about dynamically allocating. You can expect to dynamically allocate an array in there, whether it's a 2D array or 1D array or 3D array. I'm not gonna tell you, but if you want to be extra safe, practice it. And then those are the topics. Topic-wise, that's what you can expect to see on the test. So, yes. DRA. I mean, you have an IDE. You should be able to do that in 2 hours, you know. I don't see why you can't do that. So, yeah. Basically, you can expect a couple of short questions mostly. Most of the questions asked are pretty short, or at least they should be short. If you're writing a lot for one single question, it means you're overwriting. The question answer should be like 5 to 10 sentences, or words, not sentences. If you want 5 to 10 sentences, the TA is going to hate you. So don't do that. Let's see, what else would I want to point out? You should know the scope resolution operator, how to use that. How many questions are there in total again? You can expect to have anywhere from 20 to 25 questions. I'm not going to tell you the exact number because what I'm trying to do is I have a pool of questions and it will randomly pick from the pool and give you guys different tests so you can't have the same test. In theory, it should work, but I don't know if it's going to give you the same amount of questions each. It might vary by one. I don't know. So, yeah. So you can expect anywhere from 20 to 25 questions, okay? Of which you can expect to have 2 programs per se. Now, one of them is a full program, and then the other one is like code snippet, okay? The rest will be like tiny, like, you know, writing a function or something. So, but like I'll tell you, I'll give you a hint. The programming question that deals with pointers, because you'll have one that deals with pointers, and then you'll have one that deals with inheritance. The programming question with pointers is kind of cool. It has to do with Thanos from Marvel's The Avengers, so that'll be interesting. So I've always wanted to do that in a test for 202 for like the past year and a half, and I finally get a chance to do it. Are we able to look back at previous questions? Yeah, you should be. I don't see why not. I said it so you can look at the full test at once. Beware of pressing Enter or Tab when you're doing the test. So there are a platform of which we can copy. I think what you're asking is if there's a way. Basically, what I recommend personally for when you're doing the test, obviously the essay questions you can just type in directly there. I mean, if you want to copy it first in Microsoft Word or spell check it, you know, feel free to do that. Otherwise, just type it in directly. I do believe if you accidentally close out of the test, you can reopen it as long as the time doesn't expire. So that's one plus. But no, you will not be sending a C++ file. I was thinking about doing that, and then actually, I could still change it, you know. Here's what I have in the test. I have one upload at the end of the test if you want to upload anything by paper or scrapbook. You could also upload a zip file with C++ files if you would like. But my original intention is to be that you will write it on your IDE, you know, write out your code nicely, then copy it, and then paste it into the text input, but make sure you select pre-formatted so that it keeps the tabbing right. And all you gotta do is just press pre-formatted in the option menu, like you did in 135. And well, in 135 you have to type it in there directly, but here you can use an IDE and then paste it. So that should basically avoid the headache of having to type code directly there. And that's what I recommend. So my tip for you is, before 5 p.m., I would have up and running a VM that's fully working with an IDE or some sort of at least Visual Code or something, and a compiler that works. Because if you rely on Sally, so will the rest of the class. And you know what happens when a lot of people try to use Sally at the same time? It crashes. And you don't want panic during the test that the Sally crashes and you lose your assignment. The test doesn't require you to do that. In theory, you should be able to code everything from here to the paper or to the submission. You don't need an IDE. The questions are not that hard. However, it's nice because you might forget semicolons and things like that, right? So it's nice to be able to compile and test the thing works. Similarly, you can take my code, put it in the IDE, add the function that I require, and then check it, and then make sure that everything else is good, right? So you have that big advantage that people don't usually have when they do this in person, because it's too difficult to get that going. So everybody would need to bring in like laptops, or we'd have to have a computer lab. So take advantage of that by being prepared. You know, make sure everything is fully working, because when the time starts, and when it ends, it ends. So yeah. pointer questions, you can expect to see some output and be like, not more than just what is the output, because I mean, you can just copy and paste this and run it, you know. More than that is going to ask you as to why something is the output, you know, the why of something. Because then I know if you understand it versus you just plugged it in, ran it, and gave me the output. Yep, it is due at 7. It'll be like a Canvas quiz, just like you did the syllabus, or not the academic conduct quiz, same thing. Will there be a sample output for what a program can be compared to? There may or may not be. If there's not, then you will kind of do your best to make it look at what the prompt asks. Okay. Yep, indeed. So you have 2 hours, and the time begins at 5 and it ends at 7. If you are late and you start at 5:30, then you have an hour and a half left. So yeah, even if it says, by the way, because it might mislead you. It might say you have 2 hours left and you start at like 5:20, but it will still cut you off at 7. I think it won't even let you submit. So don't gamble with it. Submit it like at 6:59. Yes, the Marvel question is the full program. Yes, and I think that one everybody will get because I didn't want to make 20 different programs. What else? That's it, because there might be questions on your assignments as well. In which case, if you have the assignment, you can copy and paste that function. I'm not going to ask you like, yo, what is the search function in the Twitter assignment, and then make you code that. If you don't have it, you're screwed, kind of thing. But there might be things related to the assignments. That's it. That's the test. I have it as a PDF, but I have the questions uploaded. There may or may not be a bonus question at the end. So if there is, that is optional. It'll say it's out of 0 points, but I'll manually add it in later. How difficult do you think the test is going to be? Well, if you took 135 with me, it's going to be way harder than that test. I can tell you that much. Unfortunately, there's no way for me to really tell you, because if you haven't taken a test from me. You can expect it to be long, and you can expect to run out of time if you don't actually answer questions with short answers. Like, you can expect to run out of time if you don't do that. And the reason I'm telling you that is because I don't write too much, because I don't want you guys to run out of time. Okay? So, yeah. And yes, I know the answers because I made the test, so it's kind of tricky. Let's put it this way. If you have no trouble with the assignments, and you have no trouble following the lectures, then I guess the test is easy. But then again, it doesn't tell you much either, right? Because you're like, if you had no trouble with that stuff, then you probably needed the class in the first place. So it's just a question of take the test and wait and see kind of thing. Just practice coding, and you'll be fine. I don't see a problem with. You shouldn't have to memorize anything for the test, as long as you have your notes handy for anything that I could ask. You know, like, what is the address operator for? You know, if you know what it's for, it's because you've been using it, right? You may not remember the name address of operator, but you might, you'll be like, oh, what's the ampersand? Okay. So yeah, I wish I could tell you more, but it's just one of those kind of wait and see. So cool. Again, if you have any problems with the test, post on Discord with a TA, and also don't discuss the test on Discord. However, when the test finishes, like after 7, then feel free to discuss the questions, and I'll make the test public so you can see them and we can talk about them. But before 7, don't discuss the questions at all, because people might still be taking the test. After 7, then you can be like, what did you get for this? You can even post a solution to your Marvel questions if you want to compare them and so on. Okay, but don't do that before 7, obviously. Yes. So if you find a question that is wrong in the test, just say that it's wrong and move on. You don't need to contact us. I'll try to be available, but again, I don't want you to be limited by that. If there's something wrong, we can take that question away and so on. So yes, just take the test, do your best. Good luck. I'll be in touch over the weekend with you guys so we can talk more about this stuff, about the test. But if not, then that's pretty much it. That's the class. At this point, just go and study is the wrong word to use at this time. I would say practice, because really with programming, it's not about studying it, it's about practicing it. So go
You're already home probably because you're watching this. You could be watching this from Python theory. So go home if you're not home and just write C++ code. Do assignment 8. You can do assignment 8. That's very good practice. Do assignment 5, which is the remake of 1 with dynamic stuff. That will be good practice for that. That is how you can study for this test, is by practicing C++. So good luck. I will cheer on you guys to all get A's. And, have a good day, guys. So bye and good luck.